about 5 years back, it was unimaginable that there will be a computational metaphysics. But now we are having this first speaker, Dr. Christoph Benzmuller, who received his PhD in 1999 and his habilitation in 2007 in computer science from Saarland University, Germany. His research focuses on the automation of expressive logics in computer science, artificial intelligence, mathematics, and philosophy. In 2012, he was awarded with the Heisenberg Research Fellowship of the German National Research Foundation. In this position, he is currently affiliated with FU Berlin, Germany, and with Stanford University, USA. Professor Benzmuller.
That's fine. Yeah, good morning. Can you hear me, everybody? It's a great pleasure for me to be here. It's a wonderful event, and I'm particularly pleased to see an event like this brought up, which actually is trying to bridge between topics and science over the different disciplines and spirituality and ethical questions. I think that many of the big problems today can only be solved by having a discussion like that. And therefore, I'm very pleased to get in contact with the organizers of the event and immediately responded to the invitation to come and present our work here. So you see, I'm a logician, so I'm brought up as a logician mainly with a logics background, and I'm now entering here an area where I'm more or less confronted now with very deep questions, and that has been only recently the case. So my talk will also be more from the side of the logic perspective on what I'm going to present you. And I give you a sketch what we're actually doing in this talk. We will bridge between disciplines, between the wide variety of disciplines. So what we are starting with, and that's the foundation of my work, and that explains why I'm a logician, and this is actually mathematical logic, the logic that has been proposed by Alonzo Church in the beginning of the last century as a possible foundation for mathematics. So that's classical higher logic. That's my starting point. And then I've been working for many years and tried to automate this logic, to get it on the computer, to get it running automatically to prove theorems in such a logic formalism. And I've worked for many, many years. And then we got success over the years, and then I entered this question. So that means we are now in computer science. Yeah, we get these logics running on the computer. And then I've been working in direction of thinking about, well, now I have this mathematical logic, but in philosophy, and when you want to do things in metaphysics, in theoretical philosophy, for instance, then you need non-classical logic, a different sort of expressive formalisms. And I have been researching in this area on how can we bridge from what we have already, mathematical logic, and then machine implementation of that, and now the challenging question of how can we get very expressive non-classical logics to run on a computer. And that was then more or less a question that's also kind of in the area of artificial intelligence and computer science, but we are getting now more and more in the area of philosophy, theoretical philosophy as well. And then when that was done, this work, I was always challenged by the question then to look at something like the ontological argument for the existence of God. And I was aware of the work of Kurt Godel for some years, and that is actually what I'm going to present you today. So the last bridge we are going to build is now to look into Gödel's proposal of a formalism that deals with the question of God and derives a statement necessarily there exists a God, and we were interested in analyzing this ontological argument for the existence of God with the machinery we had developed with the computer. And this is the story of this talk, and I hope to get you on a journey and see a little bit of what we have done. And I have to pay, do you still hear me? It's fine in the room? I have to pay a tribute here to Bruno Wolzenlogel, a colleague of mine. He's now in Australia. This is joint work. There are many other colleagues involved that have helped actually to get this expressive logic formalism running on the computer. So a big thanks to them. Without their support, this work would not have been possible. Yeah, let me start with the presentation. This is a picture of Kurt Gödel, and maybe some of you in the room have been gotten aware of this work of ours by the newspaper reports that were out there. That here was a newspaper report that appeared in Germany. That was 2013, where we then succeeded first with getting this piece of ontological argument running on the computer. And shortly it became international. So that was an international newspaper appearances. And you see it was also here in India in the press. So maybe some of you have seen these newspaper reports. But actually I wasn't too happy about these newspaper reports. This is another one. You see that even made it on the front page of some newspapers in Germany. And I was not prepared for such a media interest in that topic. So far I was a silent researcher, and suddenly when I touched now this subtle area of ontological argument, then the media got very, very interested. And I have to say, I was not very, very pleased by the way many of these reports actually reported on our work. And I wasn't very pleased on the headline creation and so in the media. But I also have to say that I made some mistakes in that. And for instance, when I was interviewed by a person from Spiegel online, actually Tobias Hörter here, he had a deep logic background, he had a philosophical background, but during the interview he asked me, when you did run these experiments on the ontological argument on the computer, which supercomputer cluster did you use? He was aware that in Berlin we have some relatively good computers at Freie Universität Berlin. And then I made a mistake during the interview because I said to Tobias Hörter then, well, you don't need any supercomputers for doing that. It runs on and that was the mistake, it runs on my MacBook. I shouldn't have said that, because what was happening now is that he mentioned this issue twice in his article, MacBook, but it's not relevant at all. It runs on any kind of computer machinery, of course. Any computer scientist would immediately sign that. And what was happening now, these media persons, in particular, those who didn't like the story, they actually put the focus on this. And eventually, when the message then came over to the US, it appeared like this in the headlines. This is, you see how the media is dealing with it. Then suddenly it gets out of your hand, and the story is out, and you can't really explain what happens. And I'm very pleased that I have the opportunity here now to talk about what we really did, what we found out, and what this machinery, this framework of computational supports for doing now experiments in metaphysics and touching such questions, how that framework can eventually help us in doing so. And actually, here's the overall motivation, and that's going back to Leibniz, vision that's probably known to many of you under calculemus. So Leibniz depicted these two philosophers. They had an argument. They couldn't agree on who's right and who's wrong with that argument. And then Leibniz said, wouldn't it be great if we would have a general formal language, a very general mathematical language in which we can now ask these persons to write down their arguments formally, pen and paper. Leibniz called this language characteristica universalis. And then he said, wouldn't it be great, once that's written down, if we then could use this associated calculus, so this machinery, this computation machinery, to find out whose argument is logically correct and not. And that is an inspiration, or that was a motivation for us to look at this, whether we can do some experiments like this. And what we did is we picked now out this ontological argument for the existence of God. It's out there in Western philosophy, at least since 1,000 years. And maybe I learned here at the event even more about the tradition. There might even be an influence by Avicenna, and maybe even philosophers from eastern part of the world, which I'm not aware of yet. So this has a long tradition in Western philosophy. And in our work, we focus now on Kurt Gödel's, a famous logician every mathematician knows about, version of this proof. And this version requires a very expressive logic to deal with, and this is a higher order modal logic. I say a little bit more about that. Hopefully don't have to go too much into technical details. And what we then did is we did then experiments with computer programs, so-called theorem provers. So theorem provers which can try to find proofs automatically on a proof. And our idea was, can we verify that sketchy argument that was out there by Kurt Gödel and many others that followed the work by Gödel, more recent papers. That was our motivation. Can we look at that, and can we use computer technology to clarify whether these arguments are, from the logic perspective, correct? Okay, there are of course many different interests in ontological arguments. Philosophical interest is of course shedding a light on the boundaries between metaphysics and epistemology. Theistic, very important one is also, can a successful ontological argument convince us that there's a God existing? And our main motivation from the beginning was this computational metaphysics view that was actually originally brought up by Leibniz. So we wanted to have a study in this direction, whether we can do at least have some success now for this particular ontological argument. There is also more personal motivation here in the story, because I gave a presentation at the Kurt Gödel Society in Vienna in 2012, end of 2012, and at the end of this talk, where I presented then this logical machinery where I can integrate logic, so taking this mathematical logic as a starting point and deal with other logic formalisms like the one that's required here for Kurt Gödel's proof, higher order modal logic. I was presenting this work there, and at the end of the talk said, now it should be possible to do something about this ontological argument, namely to get it on the computer, but it was just a proposal at the time. I pointed to Melvin Fitting's book. That's a very nice introductory textbook for people who have already some logic education and want to know more about the very specific logic background about that. So this is a good suggestion for people to read it. And I was motivated by the book. I thought, can I get this book running eventually on the computer at some time? But that wasn't really, I wasn't really doing something. I was just proposing it at the time. And then I met Bruno Wolzenlogel. He was introduced after the talk to me. And Bruno was also interested in the proof, but also wasn't really going on with the research at the time. But then something happened. Bruno went back to Brazil and he got seriously ill. He was really in a life-threatening situation for him. And he came back and he had to go through some severe medical treatment. And it was in winter time, 2012, 2013. And that was life-threatening, and he had with his entire family, everybody knows that in the room, you have a really a tough time you go through. And he was supported by a church back in Brazil, and as a gift, he wanted to show this proof then to the priest he was supporting this family afterwards. So he came back with a motivation to get that work running, to look into this argument, to get our research started. And then he contacted me, and we had in the beginning a kind of race where we were more or less trying with different approaches to make it working. And in the end, then we joined forces and worked together, and that was when we had our first successes. So that's a personal motivation. So now, what's about my talk? And I need some person who is actually showing me when I have just 10 minutes left that don't run over time. So I give some overview, what's the ontological argument for the existence of God. Then I show you the versions we are interested in, Gödel's modern variant of the argument. And there are two versions, and it's getting interesting because it's not clear whether one version is correct or the other. And we wanted to clarify that. And then I tell you a little bit about the story on how we can automate the computer. I may have to skip here some slides. They are anyway technical. We should be too technical here, but if people are interested, I'm here. Talk to me. I'm happy to explain everything I can do within the next 3 days. And then I show you the results. So can theorem provers really, so computer programs, can they contribute relevant knowledge in analyzing such arguments? And that is where I want to put the focus on, so I shouldn't spend too much time in the beginning. And then I show you, in the very end, point you to recent study, because there's recent publications out there on the ontological argument. The debate is kind of still open what the status of the argument is, and our recent work focuses now also on analyzing these more recent works with the computer, so not stop where we have been starting with. And then, I find a word on related work and conclusions. So, the ontological argument is a deductive argument for the existence of God, starting from some premises. Oh, I have here a pointer which Copy is a bit distracting. Starting from some premises which are justified just by pure reasoning. That means these premises where we start from are not dependent on observations in the world. So they have to make sense by pure logical reasoning. And this is why we often call such arguments a priori arguments. There are other arguments for existence of God which are called typically or classified as a posteriori arguments because they use observation of the world. They use experience in the real world and argue from there. For instance, a cosmological argument or argument by moral observations. Okay, so we're here dealing with an ontological argument, a priori argument. Pure a priori reasoning. We want to start with a definition with some assumptions we start with and conclude, and they have to be well chosen, and then conclude by deductive reasoning that necessarily a God exists. That's the idea. And that has a long tradition. And I said it's going, at least from Western philosophy textbooks tell you, Anselm of Canterbury was the first one that was mentioned, but I know that Avicenna has a related argument out there, and maybe there's much work I'm not aware of. So Anselm of Canterbury started with proposing this idea, and his notion of God was as follows. So he said, and that's now the assumption he started with, let us say that God is that than which nothing greater can be conceived. And he says from that definition alone, we should now be able to conclude that God exists. And how does it work? He said, yeah, if we accept that definition in our mind, and if we at the same time now assume that this God we are thinking here is not existing in the real world, then we have a problem because now existence in the real world would certainly make that entity more perfect, greater, and that would violate the definition here, so hence God must exist. Okay, very simple argument. Some persons would say most nearly naive argument, but it has nevertheless survived in philosophical debate over the century. There has been strong criticism, for instance, by people who actually are pointed here in red, but there has also been criticism by people, some of are written here in blue, which have criticized but also improved it. So there are proponents and opponents to the argument. And one, for instance, proponent of the argument who tried to get rid of some of the problems is Leibniz. So Leibniz said, okay, there is a problem. I know that the argument fails in the sense that it is already pre-assuming that it's possible for God to exist. Okay, but if it's not possible for God to exist, then the argument I just gave you does fail. It doesn't work. And so Leibniz said we have to do something about it. The possibility of God's existence should be derivable also from the axioms. Others criticized. Kant, for instance, heavily criticized. He says the argument, just as I mentioned, it takes existence and uses that as a predicate in a naive way, and that shouldn't be allowed. Others criticized and said, oh, the argument is not properly distinguishing between contingent and necessary truths. So truths that are just happen to be the case, the weather today, and things that are necessarily the case. And Godel addresses these critiques. He tries to address these critiques. He was reading the literature and he tries to deal with it. So his notion is related. So he says a godlike being possesses all positive properties, and he gives an axiomatization, or he gives some criterions for what positive is supposed to mean. We will see that in a second. And then he derives, in his conclusion, necessarily God exists. So he tries to make a distinction between contingent and necessary truths. He says necessarily God must exist. It cannot be different. And you see here, that for that reason, he uses modal logic. And this is a modal logic operator. This box operator stands for necessarily. So I have to teach you a little bit of these logic notions, because otherwise you won't understand some of the slides later. So you have this box operator. Box phi stands for necessarily phi holds in this context here, and the diamond operator possibly phi holds. So we want to make a distinction between possible truth and necessary truth. And then we have classical logic operators. These are the ones you see here on the slides, probably many of which are familiar with, the typical not, or, and implies. So these are the constituents of our logic language, and we have quantifiers, and even quantifiers over sets and functions and properties that makes it a higher order logic, and then we have modal logic operators in addition to that. So that is roughly the framework you need to deal with Gödel's formalization of the ontological argument. And we have a look at that now. So this is Jan Kurt Gödel, and I mean, Gödel came up with fundamental results in computer science and mathematical logic, so he's one of the biggest logicians out there, probably, and very few people know that he was working also silently on the ontological argument. It's little known about the spirituality of Kurt Gödel, and I don't want to make any comments on that because I simply don't know. Only thing I read from a book that his wife said that he was regularly reading the Bible on Sundays, but he wasn't openly religious or so. So very little is known about that, about his motivation. I personally think that Gödel was pretty much also inspired by the idea, by the same question as Leibniz raised. So by the question, is the development of formal logic now did it go far enough now so that we can handle a thing like the ontological argument formally within a logic setting? I think that was also a main question for him, in addition to potential spiritual questions. So that scriptum here of the ontological argument was found after Kurt Gödel's death in his Nachlass. And because he was silently working on that, hardly anybody know about it. But in the beginning of the 70s, when he wasn't feeling so well, he was talking to Dana Scott at the Princeton University. Dana Scott, another prominent mathematician, logician, and philosopher, is living now in Berkeley. He was talking to him in Princeton about that because maybe he was afraid that the knowledge about his work on the ontological argument would get lost. And Dana took notes, and Dana then presented a version of the ontological argument in Princeton in a lecture. And that became public first. So there was a second version that became public first, and this is this one here by Dana Scott, and the other one was found later in Kurt Gödel's Nachlass. So here you see how the argument goes, and what the task now is. So we have the things included are the axioms, that are the assumptions, that are the things we have to start from, so that we more or less have to accept them. If we don't accept these axioms or definitions, then they fail. Then the argument is relatively useless for us. And then from this argument, from these assumptions, we conclude the things in cream, the theorem 1, theorem T1, corollary C, the theorem T2, and finally theorem T3, necessarily God exists. And you see here that Gödel is addressing Leibniz's critique because theorem T1 says, corollary C says possibly God exists. So this critique by Leibniz that the possible existence of God should be derivable is here taken up by Gödel. So he has a derivation of possibly there exists a godlike entity. And you see, he starts here by characterizing the notions of positiveness. So a first statement, either a property or a negation is positive, but not both. A property necessarily implied by a positive property is a positive property. So these are the relative weak assumptions you have to make about notion of positiveness. He doesn't say more. He doesn't need to say more about positive in order to get the proof through. And then he makes the first theorem, positive properties are possibly exemplified. And he comes here now with the essential definition, D1, a godlike being possesses all positive properties. And the property of being godlike is positive. That's another assumption we have to work with and accept. And then he can come up with the corollary, possibly God exists. And then he continues by postulating that positive properties are necessarily positive. And he defines a notion of essential properties of an individual. And they are such that they are possessed by the individual, which is this one here. So this is an essential property of the individual, so it's possessed by the individual. And for all other properties that are implied by this very property phi here, they are also, and this core property, the essential property, is implying all the necessary other properties of this entity. So it's a kind of logical core, you can say. And then we can derive theorem T2. Being godlike is an essence of any godlike being. And we need two further definitions. Necessary existence, it's not well chosen by Gödel, because that, again, sounds like the critique by Kant using existence as a predicate, but when we would have more time, we could discuss it. I think he tries to escape that here, but he uses, nevertheless, this word, necessary existence, in an unfortunate way, in my opinion. And he says necessary existence of an individual is the necessary exemplification of all its essences, which can be formally written like here. And then necessary existence is a positive property, and from that, he then concludes necessarily God exists. Okay, so if we would have more time, we could now discuss all the axioms and question them. Unfortunately, we can't do that here now during the talk, but we can, I'm happy to give my comments offline on that. Here you see the use of modal operators. For example, we distinguish between possibility and possible truth and necessary truth. I've mentioned that before. Here you also see that the quite ambitious logic, because we do quantifiers over sets, or here it's these properties. So the notion of godlike is defined as for all properties phi. And these are really properties. You see it here, it's occurring as an argument, but here you see that the property is applied to an entity X. So it's a quite ambitious logic. And this here is a main difference to the scriptum that was found by Godel. And here it's getting interesting. If you leave this little difference out, then something very strange happens. The one version stays consistent, the other ones becomes inconsistent, so we can derive falsity from it. And that means on Gödel's original scriptum there is a logical bug, and that was not detected so far by philosophers as far as I'm aware of. And that's actually what the theorem provers could help us with. Okay, so very few words on automation on the computer. I give you the problem. So in the beginning, we had no provers available for this very ambitious logic. So we didn't know how we could deal with that on the computer. And our solution was, and that was what I was working on for a couple of years, is use this mathematical logic, which I used as a starting point, as a meta-logic, to talk about the particular logic formalism we are interested here in, using this meta-logic, so indirectly. And then use existing theorem provers, existing machinery to actually do the automation. And then these here are some examples of the systems that are out there. So the Leo 2 system is my own theorem prover, which I have developed over many years in Saarbrücken and in Cambridge at the time. And there are other systems out. For instance, the prominent interactive mathematical assistance systems, Isabel Hall, Hall 4, or the Koch system. So these are all prominent systems out there that can be downloaded from the internet. Everybody here in the room can use them and play with these systems. Okay, so what I said is we use then this mathematical logic, classical higher logic, as a meta-language, like you do it in a textbook when you informally talk about other logics, and then talk about the syntax and semantics of other expressive formalisms we're interested in. And these were the ones actually we needed here, namely higher order modal logic. So that was the technical aid we were working with. And now I have to skip a few slides because I think it's getting too technical. You just see here the sketches. We have this one meta logic, and we have the logic we want to work with, the one we need for Gödel's argument. And what I come up with is then a set of equations which actually link the connectives, so this logical connectives like the OR operator or the box operator you have seen, to the language in Plu, so the meta language. And this set of equations then allows it to me, together with some equations for metalogical notions like validity and satisfiability of formulas, to give that to a theorem prover and use that theorem prover now for the logic in red. And that is what we have done. I don't go through this here. You see that that's now the concrete instantiation for the logic of Godel to make that work. So this is a set of equations which I pass to the theorem prover, and then the theorem prover can do things like that. If I state, for instance, possibly God exists, then I can represent it in the theorem prover more or less in the same way, and the theorem prover has access to these equations you have seen on the previous slide, and he can unfold these equations and rewrite that in the Plu logic. So that's on an interesting translation between the logic formalisms here, which we have exploited. And that was very important to get that at all running on the computer. There was no machinery so far for this very expressive logic that Gödel's argument requires. So what are we doing in order to prove that a formula is valid in the red language? We just map this red language with the formalism I have sketched here, and then use the theorem provers for classical higher order logic together with the equations you have seen, and then we can do the experiments. And I have proofs. Of course, I had to work out that the theory is nice, so I have proofs out that the translation is sound and complete, the typical proofs you have to ensure and make sure that that works. So that was the background story. But the point here is, Godel in his scriptum doesn't tell us exactly what the logic he is using. So not only the assumptions, the axioms, and the definitions are kind of parameters we have to work with or we have to accept, we also have to accept the question, what is the concrete logic. There is not such a thing like the logic that is commonly accepted as the one that should be used in such a context. So many people actually out there assume that logic S5, a very strong modal logic, I can't go into the details unfortunately, is the one that was used in these experiments. And then a relevant question, and this relatively strong logic S5 you get from a base logic K, which we have encoded so far by just postulating further principles. You postulate simply further principles, which we can easily do. And then you get to a logic KB, for instance, by saying that everything that's contingently true is necessarily possibly true. This is this B axiom. Then you get to a logic KB, and if you add then further of such principles, then you get up to S5. So that means S5 has very strong principles available which we can use to build proofs, but which may also lead to criticism by people, which say, I don't accept this logic. This is too strong for me. And you see here, this is a theorem in S5, which many of you may eventually not accept. This says that every formula phi that's possibly necessary is already necessary. This seems very strong, and that means if now Gödel's ontological proof is analyzed and running only for logic S5, then there are people out there who have papers who said, oh, that might be in too strong logic to work with. And our idea was now, can we clarify also the question, what exact logic do you need here in order to get the proof through? And the theorem provers were supposed to help us with this question. And you have seen the animation in the very beginning. This here is my theorem prover running on the final statement, the theorem T3, and you see that goes very quickly. Gödel's theorem T3, he's searching for a proof found. So that's just a few milliseconds, and that worked. And that was the astonishing thing. We didn't expect it, that the theorem provers were already so far developed that they could deal with the ontological argument in such a way. I have another little demo that gives you a glimpse of the experiments we had. This is this one here. This is the Isabel mathematical assistant tool, an interactive theorem prover, but it has automation facilities inside. For instance, there's the statement, theorem T3, necessarily there exists God, and now I can call a tool which calls my own theorem prover remotely over the internet running in Miami, and that comes back with the proof, and now there's a procedure in Isabel which minimizes the dependencies so that I can, in the end, exactly get aware of the question, what exactly have I used? Which axioms have I used? You see here, A2 was used, the axiom A3 was used, A5, the definition of God, and one of the axioms in the modal logic cube, and so on. So I get precise knowledge about what exactly I need for getting the proof through. Okay, so that's, I think, now enough of logic specifica, but that gives you an idea on how we were running these experiments and what machinery we could use. And we duplicated the experiments. We run it with the theorem provers independently. We did it with the interactive prover systems and even with different interactive prover systems, so to get assurance that nothing here involved with programming errors, for instance. So therefore, we duplicated all the experiments we had, or even tripled them. Okay, let's now come to the results. That's the interesting part. So could the theorem provers actually help us now to find something new out about these ontological arguments, eventually detect errors or confirm them? And that's what we did. So we looked here first on the ontological argument in the version of Scott. Okay, so that was proposed by Dana Scott. And here you see we passed now the first theorem to the theorem prover, and then Leo and Zatalax, two systems, came back quickly in a few milliseconds, and they say, yes, verified, T1 follows, and it follows already in this very weak modal logic K. We don't need S5 for that. We don't need this strong criticized logic for doing that. And we did more experiments with respect to different notions of quantification, but I think that's going way too far of what I can actually explain here. So that means we did vary the different logic settings and found out K is sufficient and different versions of quantifiers don't play a role. Then we did give it the next statement. Possibly God exists, and the theorem provers came back again in a few milliseconds and told us K is sufficient. The principles for S5 are not needed, and quantifiers also don't play a role. You can get the result for both versions. Then we gave it the next statement, T2. Logic K is sufficient again. Few milliseconds by Zatalax. Leo needed a bit longer. He needed a few seconds for this one. And again, the exact dependencies you see from which it follows. And then also, again, the independence of the different quantifiers. So now in the last step, it got more interesting because our experiment for logic K failed. The T improvers didn't come back. They run then infinitely long. The problems here we are dealing with are non-decidable problems, so we can just do proof search. The T improvers, my one didn't come back, and Satalek said gave up. So we couldn't say anything about it. But there are other systems out that can find counter-arguments, counter-models, counter-arguments. And this system then told us, oh, for logic K, TMT3 doesn't follow. So it's not the case that we have necessarily the accessible. And then that was in logic K. But then we moved a bit up in the logic hierarchy and gave it the B principle, logic B, the B principle we've seen, and then it worked. Okay? So now the T improver actually came back and told us, yes, necessarily God exists, and we have verified that for this setting, logic KB. So the entire argument goes through let me jump here, goes through in logic KB, and S5 is not needed. And that is a philosophically interesting result, because S5 might be criticizable, KB is much less so. And it doesn't depend on, for instance, different notion of quantifiers. But we also, what we did is we looked into the question of the axioms or definitions are consistent. And this is this here. The model finder nitpick told us also that. So also the consistency of the axioms could be verified by the machinery, which is an important one. And I come to that back in a second. And what is also interesting, T improvers often find alternative proofs which are different from those that are generated by humans. For instance, in many textbooks on the argument, you find self-identity, the property of being self-identical used in the proof. And this is not needed. You can do the proof without. So this property might also lead to criticism from different angles, and you can do it with other properties instead. And what we have seen in the experiments was an excellent match between the power of the computer systems and the argumentation granularity we found in these papers. Okay, but now to show you what the T improvers can also do, they can tell you whether an argument fails. So Scott's version of the argument is okay for logic KB. We have verified the result, we have consistency of the axioms, but how about Godel's proof script, the original one, if you leave out that conjunct? So with the machinery, we can simply modify now the definition and rerun our experiments. It works very well, but in this case, it's very interesting. We get an inconsistency result. So this argument doesn't work if you leave this conjunct, the requirement out, as you found it on Godel's original proof script written down. And this has not been reported in philosophy papers, even though many people out there have used the argument and criticized it with other means. But this is kind of meaningless, criticizing an inconsistent set of axioms. So that means the T improvers could have helped here to prevent the discussion from in the papers going in the wrong direction. Okay. Unfortunately, so my T improver told me that these axioms are inconsistent, but unfortunately, that was what I got as a result. So this is unreadable. I mean, I'm the programmer of that, and I had a hard time to understand that. So I wanted to know, why is there now inconsistency? Why does the argument fail in this case? And there's a communication problem between this computer program and myself. I didn't understand it for a long time. And in the end, I have to admit that a discussion with a colleague who is deeply also a logician and familiar with the work I've done here, Chad Brown in Saarbrücken, helped me to understand the argument. If someone is interested, I can explain it in a few words now afterwards. It's a bit too much now here for the presentation. But the key question is here, the key issue here is that the idea of the proof is in there. I simply wasn't able to find it. Once I had detected it myself afterwards, I was able to see that the prover had the intuition about why the argument goes wrong. But it can't explain it to me on the level I would expecting that. So there's a kind of communication gap here that requires more research. And once understood, this inconsistency argument is very simple. And think about it if you want to have in the coffee break a discussion, self-difference becomes an essential property of every entity if you leave this conjunct out. And this is the crucial lemma. And then you see quickly that it's getting inconsistent. So You can ask now the theorem provers, let's get back to the version that worked, namely Scott's version. So we have a version of the ontological argument that works, and now the question is, can we prove further theorems? And you can get this one also as theorems proved from the axiom, namely that monotheism holds and that we have a flawless God, which reads in a mathematical reading like you see it here. Theorem provers can also tell you that those two statements follow from the axiom. And unfortunately, and this is now a real problem of the ontological argument, also by Dana Scott, they can also prove you what is called the modal collapse. Remember that we were starting with the idea, Godel introduced his idea of introducing these modal logic operators to distinguish between necessary truth and possible truth. And what is happening here is now the axioms are so strong that you can derive this statement. For everything, for every phi that's contingently true, that implies it's necessary truth. And that means we can also get this here as a corollary. We can also get this as a corollary, namely that possible truth is equivalent to necessary truth. So the whole idea to introduce modal logic to act on a critique is kind of brought to absurdity now, because you can derive the modal collapse from that. That seems a very strong critique. Of course, it's only a strong critique on the argument for those who don't believe in determinism. If people are out there who anyway think that everything is determined, it might even be a very pleasing result, because you start with a modal logic which doesn't have that principle, that contingent truth implies necessary truth. Then you come up with the definition of a godlike entity, and then in the end, from that definition, you follow again, you conclude again determinism, or that you can even say that it means there's no free will. So that is a kind of situation that might be pleasing to a few people, but it might have many more critics out there. And this is unfortunately something that holds now for the ontological argument in the version of Scott. And that has triggered a lot of research. Therefore, there are many papers out there which try to repair that. And for instance, Anthony Anderson or Petro Hayek have worked on that. Hayek is a logician in Czechia, and Anderson is a philosopher. I think he lives now in Santa Barbara. They have tried to fix that problem. So to modify the axioms and the definitions to have the result you want to have, but nevertheless avoid the problem of the modal collapse. Okay? And these are papers we have also looked into with our theorem provers. And there was, in particular, one interesting thing, namely, there was a dispute, a philosophical dispute, in the sense of Leibniz probably, going on between Petra Hayek and Anderson in the footnotes. That's how philosophers do that. So in the footnotes, they both blamed each other of being wrong with their suggestions. So the one said, oh no, your formalism doesn't solve the problem in an appropriate way, and they claimed each other being wrong. And now, in the end, it was the case that Petra Hayek, the logician, gave up over the philosopher. And he shouldn't have done so. We have now formalized the versions, and it seems that Petra Hayek, with his claims, was right. But the thing, he took then later on in further papers the position of Anderson in a point where he shouldn't have done so. And the theorem provers could clarify that. And that is very encouraging of what the technology actually can do here. Because we can actually have a look at such papers and try to find out really, at least on the logical, pure logical level, who is right here and who is wrong. And we can really make all this logic fine-grained assumptions in the background explicit, because that's what you need to do when you want to run these things on the computer. You cannot leave anything implicit regarding the particular logic settings you're using with. You have to make this explicit, and that contributes to clarity about those arguments, as I think. Okay, how's the time? I think I should stop, right? So let me come to a short discussion and conclusion. So what I think is, you see here first attempts in the direction, and I'm not the first one who've done that. Edward Salter at Stanford University has done experiments on Anselm's proof before, and Schenker at Stanford Research Institute, John Rushby, not Schenker, John Rushby at Stanford Research Institute has also done experiments before. So we see the first experiments in this direction of what was Leibniz here proposing, namely that we can pick out philosophical arguments, even such extreme important arguments like the ontological argument, and try to analyze them with computer machinery, and by doing so, contribute to clarifying misunderstandings or settling logical questions on those formalizations. And we have seen here first step in this direction with this work. But nevertheless, I have to address also this point here. The reaction to the media reports were unfortunately mainly negative in the press. And so if you can go to this website, for instance, Spiegel Online, and then you see how the bloggers react to that. And that is a kind of very interesting thing to do, to see what the wider public in Germany, in France, in other countries, actually, how they react to, for instance, to the ontological argument. And then you can try to come up with possible explanations. And I have to say, I think, in particular with the ontological argument, and a certain and not too low level of logic education is unfortunately required to really understand it. And very often you see that these bloggers run in very simple logic errors in trying to attack it. So I think that's a point that it might be really mandatory that you have a certain level of logic education to really be capable of understanding what's going on here with the ontological argument or what it tries to do. Otherwise, you might try to criticize the notion of positiveness and the axiom on that on a too uninformed basis, maybe in a sense. So that is things you can find out by looking at these reactions to the bloggings. And I think another problem is that there are unfortunately very few textbooks out in philosophy which allow you to quickly access the importance and the story of the ontological argument. You more or less have to read through the entire history or through many of these papers on the ontological argument to really get a feeling for it or be pleased by it. And then, of course, I think also the obfuscation in the media reports contributed to negative reports. I mean, if you're obfuscating what we have written in our paper by putting headlines out like this, that triggers very strong reactions, and you could see lots of that also in the reactions to the blogs. So a conclusion,
Professor
I think we
Muller,
have here a contribution towards what I call and what was coined by others before, computational metaphysics. And you see that even novel results, novel insights can be contributed by continuum provers, and that this infrastructure, that's a very interesting point, can be adapted for many, many other logics. So it's not one logic we are addressing, but by using this idea of a meta-logic in the background, you can play with different logic formalisms, and this seems to be important for more experiments out there. And the technology works well. Everybody is welcome to work with that. We have that GitHub repository out there, which was mentioned on several slides and mentioned here again. So everybody in the room can download our formalizations, can play with that. These systems can be downloaded. Everyone can contribute and try to come up with their own variants of the argument himself. I mentioned the related work, and I think that this is not just relevant for philosophy, but for the approach for an entire range of scientific disciplines, including artificial intelligence, computer science, computational linguistics, and maths. An interesting ongoing work is actually we want to verify the entire landscape of ontological arguments that's out there. So all the papers you have seen, I've mentioned as recent work we want to look at. We have a proposal for doing that and want to do that with PhD students. So to get most of this work really formalized on computer. That would be great if in 10 years' time or 15 years' time we could report that we have done that for most of the recent literature. So if you want to hear my position now, because of the problems you've seen, modal collapse and so on, I'm not fully convinced personally yet by the ontological argument. So there are too many questions still out there to be solved, but some of the more recent papers seem to be very promising to give a better account and avoid the modal collapse. However, what I think that by looking at now from the experimentation, what I can say personally is that the belief in a godlike supreme being is, from what I can tell from the experiments, at least not something that you could claim as necessarily irrational or trivially irrational and inconsistent. And I think that's already a strong claim. Even though the ontological argument as such may be not acceptable for everybody, but I think that is something we can really discuss, and I don't see much of attack against that. So and for me, that's a strong conclusion to be made here.
Professor
Okay.
Muller,
I think that's the end, yeah, otherwise we run out of time. Thank you very much.
Where is the thank you slide? Thank you very much, Professor Muller. Before the next speakers I call, because the topics are completely different, we can have 2 questions from the audience. This is a very technical presentation, so I expect some questions from the students or the professors who are in the computer science and the logic. They are welcome to ask questions.
Why we need to go through the ontological argument? What are the different thoughts on accepting the existence of God itself as an axiom?
As an axiom, yeah, sure. That is that would be one of the alternatives, and yeah, I think for every strong believer, that's anyway what one would do, and I think the ontological argument never intended to actually be an argument to convince a non-believer to become a believer. So I think this theistic motivation of convincing somebody of an existence of God who is a strong non-believer was never out there, not really. It was more or less Anselmo's motivation was probably, as a strong believer, to find an argument against attacks from the outside. And I think exactly what I came up in the very end, that if somebody comes but believe in a God is an irrational thing, then you can take now a thing like the ontological argument and you see, look, I get the conclusion that there exists something like a supreme being, a godlike being, just by starting from some very weak assumptions, from some much weaker premises, and hopefully much weaker. That's to be discussed. I mean, you have to start from assumptions to get to the conclusion. But you can then argue and say, I don't have to necessarily take that as an axiom. I can, even with a mathematical theory, reduce that to some weaker assumptions, and those weaker assumptions are probably not so easy to attack than others. So I think it's a good tool to get people involved in a discussion about the notion of God in an abstract sense, and about the question whether such a belief is rational or irrational. And I think it's, for me personally, much less a tool to really try to convince somebody of the existence. Typically, the opposition would be too strong, and then the ontological argument doesn't have enough persuasive power as opposed to religious belief to convince somebody. So that's my personal conviction here.
Any other questions?
The negating part. Oh, if you want to, I mean, there have been people and said, I mean, the typical parodies. You can derive now the existence of evil by negating some of the statements, for instance. You mean that you try to prove there's not God?
That is Godel's take.
You mean the notion of negativeness as a positive. Godel in his scriptum, yeah, now I understand. Godel in his scriptum says that positive should be taken in a moral aesthetic sense. And he means in a very abstract sense, maybe connected to the idea of perfection in a way. If you simply replace that by negative properties on the axiom basis, then they don't really make sense in some places. So why should being godlike, for instance, be a negative property if you put it like this? Or why should properties that strictly follow from negative properties also be negative? So for instance, then you would have very interesting things like, then you would have to say self-identity is a negative property that would follow from axiom 2. The negative, again, I didn't hear it precisely, but again, maybe that contributes. So the negative, and a corollary here is that God is flawless in the sense that he can't have negative properties. So all the properties he can have are the positive ones. Those you characterize as positive. But there are not many in there. These are the ones that were explicitly mentioned, namely being godlike, having necessary existence. And then the ones you automatically get in a sense for free, like being self-identical. They would also be positive properties and all kind of lifted tautologies. And then from this set of axioms, you know that that a godlike being can only have positive properties. You could strengthen the notion by just claiming that that there are more positive properties out there, but that's not necessarily to get the proof through, and Godel does exactly that. So he just states these two axioms, or these axioms which are necessary to get the proof through, and then he leaves the notion of positiveness open, in a sense. And Anderson goes and even weakens one of these two axioms, so that you can even have more flexibility on the interpretation of positiveness. So positiveness is not to be taken or confused with let's say, a too concrete notion of positive in our world as we experience it. It's really an abstract sense. What do I need to put in? You can call it different. You can call it godlike properties, or you can call it whatever you like. You simply have to assure that exactly those properties must be ensured that are needed for the proof. And I think that was the idea here in the ontological argument.
Yes, I have a problem with Professor Muller. I have a problem with pure logic leading to God, being a non-technical person.
Yeah.
I am not a computer scientist and not I am a logicist. But when you say that God is that than which nothing greater can be conceived,
Yeah.
if you replace that word God by demon, demon is that than which nothing greater can be conceived. You will prove same thing by logic. You replace the word God by demon.
Yeah.
And Ravana,
Yeah, you can call it
the king of Ashura, he used to say that I am God, applying this logic.
Yeah.
So logic can, I doubt whether it can lead to God, because with these words, God, demon, positive, negative, we are emotionally attached,
Yeah.
cognitively attached, feelings-wise attached to all these properties which we describe.
Yeah.
Here comes the consciousness. Consciousness has three functions: cognition, emotion, and will. Now, we are attached to this word God, we are attached to this word demon or evil with this consciousness.
That's
Now, how logic can prove it? Logic can prove the opposite also, absolutely opposite.
Yeah, but you should, I mean, now I really have to answer as a logician here. The notion of God, as it is used here in the argument, like the notion of positive, you can replace it by any other symbol. I mean, you can replace it by any other thing. And by doing so, to have a better logic education, it's occasionally even good to do these experiments, because you have to abstract away from exactly the point you have mentioned, that we attach emotions and concrete experience in the world with the notion as we use them. And that is not what you should do as a logician. That is not what logicians do. So the interpretation only comes from what is written there as axioms and definitions, and from the interpretation freedom you have to give to that, constrained only by what is written there. And this is an important exercise logicians have to go through. So disconnect for a moment the notion of God, and then look at the axioms and look at them and question them whether they actually try to capture principles that you would typically assign with a godlike being, or at least some of them, those which you need to get existence through. And that is the exercise one has to go through, and not attach too much meaning of them from the very beginning in the notion of positiveness, in the notion of
Thank you, Professor Muller. Give him a big clap for this presentation.
Thank you.
There is a technical problem in the computer, but let me introduce the second speaker, Dr. Chandra Vikram Singh. He is known to us He presented against abiogenesis in the conference in the Allahabad, the same conference. So when I saw him yesterday during dinner time, I immediately remember that I sessioned his chair at that time also. And today morning I was told that I have to session his chair. Professor Vikram Singh is born in Sri Lanka 1939 and educated at Royal College Colombo and later at the University of Ceylon. In 1960, he obtained the first class honours degree in mathematics and won a Commonwealth scholarship to proceed to Trinity College, Cambridge. He commenced work in Cambridge on his PhD degree under the supervision of the late Sir Fred Hoyle and published his first scientific paper in 1961. He was awarded a PhD degree in mathematics in 1965 and was elected a Fellow of Jesus College, Cambridge in the same year. In the following year, he was appointed a staff member of the Institute of Astronomy at the University of Cambridge. Here, he began his pioneering work on the nature of interstellar dust, publishing many papers in this field that led to important paradigm shift in astronomy. He published the first definitive book on interstellar grains in 1967. In 1973, he was awarded Cambridge University's highest doctorate for science, the SCD. He is